Hello, my name is Evan Hassman, and this is my final project video for Advanced Real-Time Systems. So the challenge that I selected was to implement EDF and compare it to rate monotonic or deadline monotonic. And so in order to do that, I took the original RM solution that was provided to us for project 4, and I modified it to include deadline monotonic as well as earliest deadline first. So the first thing I did was move over to scheduler.h, and I added the EDF scheduling policy, so that I could easily select between which one is currently running, mostly just to make my job a little bit easier when I was testing them. Um, then I started working on the actual differences. The left screen over here is the scheduler.cpp for the RM solution, and it is the base model. Notably, it only checks to see if you are running RMS, whereas the one that I updated checks to see if you are running DM as well, because both of them will run set fixed priorities if you are doing RM or DM. And the difference here is that for rate monotonic, it checks the period, whereas for deadline monotonic, it checks the relative deadline. And so by adding these compiler time if statements, I can select whether it is checking the period or the deadline. And then I also added some print statements down here just to make sure that it was setting the right variables. It only runs at the very start of the program, so it didn't add too much overhead. I felt that it was fine and a good use to show that it was setting the priorities correctly. So after that, I started working on the EDF section of it. And so in order to do EDF, I created a function that will update EDF priorities. The way this works is that it iterates through all the task blocks. It will check to see if it's in use. It will check to see it's already used, which in this case is talking about whether I've assigned it a priority or not. And then it compares the absolute deadlines, and it tries to find what the earliest deadline is. Once it finds it, it will apply the highest current priority, and then it will decrement the current priority level so that it can begin the task set anew, and it will look to see what the second soonest priority is. And they are set using v task priority set. Yeah. This is run in the periodic code section. Every time, very periodic task code right here. So every time the absolute deadline is adjusted, it means that we need to check to make sure that the EF priorities are set correctly. And so it will run it the first time. It will update the absolute deadline here. It checks compiler time to see if we are using EDF. If not, then we don't have to worry about this step. But if we are, then it enters the critical section so that it doesn't get interrupted. It runs that little section of code to update all of the task priorities, and then it exits the critical section to allow the task to resume. And it does this once again down here because this is where it runs after it runs the first time. So it's important that I check anytime an absolute deadline is updated to make sure that it works. So that was the whole implementation. It didn't actually take that long, and that's because I accidentally left in a bug, but I will get to that in a little bit. So in order to test these, I created 4 task sets. I left task set number 1 and number 2 from the original RM solution, just to avoid modifying it too much. But starting with task set number 3, this is a light load task set. The idea is that this is a very easy task set to compute. There should be no problems with it whatsoever. And so if there were any sort of mistakes, I would be able to tell here. It would be very obvious because this only uses about 50% of the processor time. And so if any reason it would get stuck, I would know that something has gone terribly wrong. The second task set was specifically designed for an EDF to win. And so this one has a much higher utilization bound, about 1.06 or so. And the idea is that this is way above the curve for RM or DM, and it will struggle to do those. but EDF is able to use its processor time more efficiently. So theoretically, running this, it should work. Task set number 5 is a test over DM versus RM. I wanted to make sure that my DM implementation was working correctly, and so it has just some. I played with the deadlines a little bit to see that if our RM is working, it should not care about these deadlines. It should prioritize task 2 over task 1 or task 3. But if it's running DM, it will notice that the deadline for task 1 is sooner, and so it should prioritize those tasks. And I wanted to run it against EDF as well to see if EDF is able to run better than DM or anything like that. And so the final task set that I created was task set number 6, and this is an overload. Basically, this is way higher than any task set would be able to, or sorry, any algorithm would be able to process. It has a utilization bound of like 1.5-ish, and so realistically, nothing would be able to properly run this task set. But I wanted to see how they would do in a situation where they can't win. And so they have way over usage. I would expect RM and DM to just get stuck, not being able to compute anything. And EDF, I imagine, will have some interesting behavior because every time it updates, it has to run through that whole loop and set all the priorities. And so I would imagine that EDF would actually have a worse time running this task set than RM or DM. And so I began testing them by setting task set over here to 3. This is the first task that I am running, and then I set the priority to, let's do RMS to start. And so by running this code, I can output it onto this serial monitor over here. And we can see rate monotonic. It starts with task set number 3. This is the easy one. If there was any issues, now would be the time to show it. And you can see that it runs totally fine. No issues whatsoever. And so you would expect something similar for deadline monotonic. And by running it, we can see that that is true. Deadline monotonic right at the top. It sets all the priorities. And there are no issues whatsoever. And so now we run EDF, which similarly should not have any issues running this task because it's very easy, no problems whatsoever. EDF is running, and it goes ahead and runs fine. And now this was the opportunity that I wanted to take to recognize that this is not the correct output, at least for the very start. Task 1 has a deadline of 200, Task 2 has a deadline of 400, Task 3 has a deadline of 800. And so, earliest deadline first states that Task 1 should be running first, but no, it does not. Task 2 runs first. And the reason for that is because I did not call update EDF priorities until after the task started running. And so it does not get called unless the scheduler runs or one of the tasks finishes. And so that's why task 2 goes before task 1 in this instance. However, because it was so early and I didn't feel it had much of an impact on it, I decided that it was not really worth the time to resolve it. Yeah. So if I were to continue this project, I think that's probably the start where I would pick off and make sure that I didn't have any of this weird kind of issues running at the start. But I feel as though this implementation is it's good enough to show the benefits of EDF over RM and DM. So I decided to kind of keep running with it. So now let's move on to task set 4. Task set 4 is the one where you would expect RM or DM to struggle a little bit, and for EDF to fare pretty well. And so running rate monotonic on task set 4, we can see, oops, sorry, I didn't show the number. Right at the top, RM, it runs, and it almost immediately runs into a miss. And now this is one of the only misses that show up. We can keep running through this, and it will eventually hit another miss as it continues. But it's important to note that it does miss. And same with deadline monotonic. So if we switch those over and we're in the wrong one. Sorry, cancel. Let's re-upload that. serial monitor. Sorry. Yeah, so deadline monotonic, tests at 4, throws the miss right in the middle. So we would expect that to happen because it has a high utilization. And so if we run EDF, hopefully it won't have that problem. So if I run EDF over here, we can see EDF, and it does not run into a miss. In fact, it continues running without any issues. And so that shows to me that the EDF implementation, although it does have that T2 run at the very start, is not largely affected by the bug. Moving on to task set number 5. This is the task set that was designed to test deadline monotonic and rate monotonic. And so it has this very, very tight deadline at the very start, where rate monotonic would look at the period and say that task 2 has a higher priority than task 1. Deadline monotonic should see that task 1 needs to complete quickly, or otherwise it's going to fail. And so by switching to RMS and uploading the code, this is the one that should fail. Let's see here. RM right at the top, test set 5. It has that tight deadline, and we have a miss, we have a second miss, we have a third miss, we have a fourth miss. In fact, it's just going to keep on missing because it doesn't care about that tight deadline. But if we switch over to DM and we give that a run, what we should find is that it fares a lot better because it actually cares about those small things. So deadline monotonic starts running, and it runs, and it runs, and it runs, and it runs, and it doesn't have any misses. It just keeps going. And so that's great. We are happy with that. Let's see how EDF compares. Now, you would expect EDF to have a similar kind of performance to deadline monotonic in this case. And what's this? We already missed a task, and this is because of that one bug that I said wouldn't matter in the future. But I figured not only because the RM versus this task that is to compare RM to DM mostly, but also because it doesn't make another miss. So it still has that bug at the very, very start, but considering that it's running totally fine after that point, I feel that this is just kind of a superficial thing, and it kind of resolves itself after. And so ignoring that initial bug where it doesn't set the priorities at the very, very, very start, you can see that EDF does compare very well to deadline monotonic in this case, not a single miss afterwards. So that's kind of the expected behavior besides that one very, very initial bug. And so the last task set is task set number 6. Task set number 6 overloads the system entirely. It has way too many tasks for what it's trying to do. And so by running rate monotonic on this guy, what we should see are a lot of misses. Just many, many, many misses. So here we go, rate monotonic, it runs and it misses, and then it misses, and then it misses, and then it misses, and then it misses. There's a lot of misses within the first couple of tasks, which is to be expected. Deadline monotonic does not do much better. So if I run DM real quick, clear the output, you can see deadline monotonic, miss, 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 miss. So I'm going to go ahead and take a screenshot of that real quick because we're going to need it in just a moment. So we'll grab up to, I don't know, 2,800 milliseconds. All right, I'm going to put that over here. And so I'm going to switch this over to EDF. And then we're going to run the same task set. And this was the exciting part. I did not know what to expect to this, but the results actually did make a little bit of sense to me. And so we run it, and we get a miss, and we get a miss, and then we get a miss, and then we get another miss, and then another miss. And we get a lot of misses in that initial 2,700 or so seconds, right? So we got 1, 2, 3, 4, 5, 6, up to 2,800. And in EDF, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 misses in the same time period. And what I realized is that that is because of the overhead that EDF adds by having to run through the set priorities code over and over and over and over, every time a task is missed or a task is created, it has to run through this loop, and that eats precious processor time. And so by having to run through this loop over and over and over again, it's going to continuously expand upon this issue where EDF is missing its deadlines. And so to me, that made sense, which is the only reason that I believe EDF may not be the superior choice in every single case, considering the other ones that we went through, all of them worked very well. So that is my final project. I have a couple of regrets about not resolving the initial EDF bug at the start here. I believe in order to fix it, I could run the deadline monotonic set fixed priorities at the very start before it starts those tasks. I think that would be able to resolve the bug. Unfortunately, I did not give myself enough time to complete that. But that being said, I think that it was an interesting way to kind of learn about how to implement these tasks, these algorithms. And I think that were I to continue this project, I would certainly make that change. So yeah, thank you very much.